Hi everyone. Today we're going to talk about dew point and relative humidity. Let's start with what those things are. So, what is humidity? Humidity is a measure of the amount of water vapor that's in the air. Air's ability to hold water vapor depends on its temperature. For instance, warm air can hold more water vapor than cold air. Now, let's go back to this diagram that we've talked about previously about warm air rising, cooling, condensing, and turning into clouds, right? Um, so why does that happen? Let's go further in. So how do clouds and rain form? Warm air holds more water vapor than cool air. Let's think about the particles in cold air versus warm air or hot air first. In warmer air or hot air, the molecules have more energy, so they're much farther apart. In other words, warm air is less dense, so the molecules are farther apart. Cold air is more dense, so the molecules are closer together. In warm air, since the molecules are so far apart, there's more space for water vapor to um, be held by warm air, right? There's more space for water vapor to be there. But in cold air, since all the molecules are so compacted together, there's barely any space for water vapor. So that's why warm air holds more water than cool air. So let's continue. As warm air rises, it starts to cool. Remember, warm air can hold a lot more water vapor, but cool air can't. So, as warm air is rising and as it starts to cool, it can't hold the same amount of water vapor. So, that's when that water vapor will start to turn into these droplets of water and turn into clouds and even rain. So, when cool air is at max capacity or 100% water vapor, that's when it starts forming clouds and rain. So let's talk about what relative humidity is. You have the option of writing this down in your notes. I highly encourage it. So, relative humidity is how close a parcel of air is to having 100% water vapor or max capacity. And it's written in percentage. So, relative humidity just tells us how close the air is to becoming 100% or having 100% water vapor or becoming at max capacity for water vapor. For instance, if this teardrop shape was my parcel of air. This would be 100% relative humidity because it's 100% filled with water. This would be 50% relative humidity because it's 50% filled with water. And this would be 30%. Here's another example. This has a 95% relative humidity because this parcel of air, this box right here, is 95% filled with water vapor. This one is 10% filled with water vapor, and that's what relative humidity is. The percentage of water vapor that um the parcel of air contains, 100% would be max capacity. So, relative humidity is how close a parcel of air is to having 100% water vapor. So, let's think about cool air and warm air once again. Think about warm air as a bigger cup. And think about cool air as being a smaller cup. And that's exactly very similar to how it actually works, right? Because warm air, the molecules are farther apart. There's so much space between the molecules. It's almost like warm air is a bigger cup. And cold air is a smaller cup because the small molecules are closer together. So, since warm air is analogous to a bigger cup can hold more water. And since cool air is analogous to a smaller cup can hold less water, right? So that's why if over here the relative humidity is 50% in hot air. But if I put the same exact amount of water in cool air is very similar to a smaller cup, right? So even though it's the same exact amount of water, cool air would have 100% relative humidity because that would be 100% water vapor that cool air can hold, or cool air would be at max capacity with that same amount of water. But since warm air is farther apart, bigger cup, that same amount of water would be 50% relative humidity, and so on. So, cool air is more likely to reach a relative humidity of 100% because it can hold less water. That's why during evening and nighttime, when the temperature is a little cooler, relative humidity is more likely to be 100% during those times. So, when we have cooler air, we know it's much easier to go towards the 100% relative humidity. So, what is dew point? We said relative humidity is a percentage, how close we are to being at 100% capacity for water vapor. Dew point is the temperature at which a parcel of air has 100% water vapor or max capacity. So, And it depends on the climate of the region, the time of the day. It has a lot of factors, dew point. But what it really means that is in a certain location or at a certain time, a certain temperature um, will determine whether we have 100% water vapor. In other words, let's look at these, right? Say my dew point is 50 to 60 degrees Fahrenheit. That just means that in this location or at this time, at this temperature, my parcel of air will be at max capacity of water vapor. It can't hold any more water because of that temperature. Say we're in a whole different location because of the climate and other factors. That location has a dew point of 70 degrees Fahrenheit. This means at 70 degrees Fahrenheit or more, the air will reach max capacity of water vapor. So that's when it feels downright gross because at 70 degrees, it's pretty warm, right? Imagine it being 70 degrees out and the air is filled with water vapor, max capacity. Your sweat would not even evaporate because the air can't hold any more water vapor. It would feel really gross. But if the dew point was 50 to 60 degrees Fahrenheit, then the air needs to be a lot cooler for it to be at max capacity of water. So it doesn't feel as bad. It feels more comfortable. Yeah, because you it takes a lot more for the air to cool down to become that sticky and gross and uncomfortable, right? So here's an example. Let's talk about a new vocabulary word, precipitation. Precipitation is just rain. So, we're in a location, and in this location, the dew point in this region is 65 degrees Fahrenheit. That means that in this location, when the air temperature reaches 65 degrees Fahrenheit, that's when the air will become filled with water at 100% capacity for water. Okay? So, say I have warm air, this warm air's temperature is 87 degrees Fahrenheit, but my dew point is 65 degrees Fahrenheit. The air has to become 65 degrees Fahrenheit to be filled at max capacity of water, right? So this warm air starts to rise and cool. It's still not at 65 degrees, but when it reaches here, notice that my temperature of this air is now 65 degrees Fahrenheit, which is the same as the dew point. So if my temperature reaches the dew point, remember, the dew point is the air temperature at which the air reaches 100% capacity of water vapor, right? It can't hold any more water. So that's when it starts to form clouds and rain. It starts to release those water droplets, okay? The water vapor turns into water droplets. This also means that the relative humidity is 100%. Remember, relative humidity is how close a parcel of air is to having 100% water vapor. If we're at the dew point, which means that the temperature at which the air has 100% water vapor, then that also means that relative humidity is 100% because we're at max capacity of water vapor. So, in other words, when the air temperature is equal to the dew point temperature, the temperature at which the air has 100% water vapor, that also means the relative humidity is 100%, right? We have 100% of capacity of water vapor. And there's a higher chance of clouds and precipitation because the air can't hold any more water vapor than 100%. So it's going to start releasing that into water droplets to form clouds and even rain. So make sure you have your note packet out, pause this video, and write these notes down. Um, so the chance of precipitation or rain is greatest when the air temperature is equal to the dew point temperature and or the relative humidity is 100%. Remember these terms. So in the next video, we're going to talk about how to calculate relative humidity and dew point.